Students, welcome to the first class of mathematics in our school for plus 1 and plus 1 science and plus 1 commerce students. Every week there will be 2 to 3 hours classes, and after the class, the end of the week, you will have a test paper. An email address will be provided to you, and the test papers should be answered and it should be posted in the email address. 2 teachers will be taking classes for you, but for the time being, I am handling the first chapter, sets. The text that we are following is NCERT or SCERT. Along with the classes, notes will also be provided in your mobile. So copy down the virtual class as well as the notes that are given to you. Both will come into your mobile. You have to keep a separate notebook for writing the notes. Okay. So we'll start with the first chapter, sets. What do you mean by a set? Okay, very good. You said set. A set of boys. That means a group of boys. A collection of boys. Then another example, a set of, a set of, give me a set of boys having the same height. A set of boys having the same height. So these are all sets, and we know that sets means it is a group. But actually sets means, in mathematics, when you speak about sets, a set means it is a well-defined collection of objects. Well-defined collection of objects. Well-defined collection of objects. You said collection. Okay, that is correct. But a new word has come in it, well-defined. What do you mean by well-defined? Well-defined means, suppose you ask a question to 1,000 people or 10,000 people or 1 lakh people, they all should give the same answer. Suppose if I say a set of 10 boys in your class, I ask roll number 1. He'll say 10 boys. He will select 10 boys according to his outlook. If I ask another student 10 boys, what will we do? What will he do? He will collect another set of 10 boys. Maybe someone may be common to both the sets. So a set means, a well-defined means wherever you go, wherever you put a question, the answer should be the same. For example, if I ask a boy in Kerala, what are the vowels in English alphabet? He will definitely say the vowels are A, E, I, O, U. If I go to Dubai and ask as a grade 2 student, what are the vowels? He will also answer the same, like A, E, I, O, U. Wherever you go in the world, and if you ask what are the vowels in the English alphabet, you get the same answer, A, E, I, O, U. That means it is a set. It is well defined. Wherever you go, you should get the same answer throughout. Whether it is positive or negative doesn't matter. The answer should be the same. So that is known as a set. A well-defined collection of objects is called as a set. Okay. Now, let us consider another example of set. Natural numbers. Natural numbers. Wherever you go, you ask natural numbers. You get the same answer. What is natural number? 1, 2, 3, 4, 5, etc. and so on. This is natural number. Will there be any change if you change country to country? No. It is a set. It's well defined. Then comes, it is denoted by the notation capital N. You have to note all these things, capital N. Now, the set of whole numbers. The set of whole numbers. it is denoted by the letter W. What is the set of whole numbers? It is 0, 1, 2, 3, 4, 5, etc. etc. Now, next one, integers. Integers denoted by the letter Z. Z. And when you consider integers, there can be negative integers, -2, -1, 0, positive integers. This is also a set. Then comes rational numbers. Rational numbers. It is denoted by the letter Q. Q. There can be positive rational numbers or negative rational numbers. 1/2, 1, 2, -1/2, 2/3, etc. Then comes the real numbers. Real numbers denoted by the letter R. It contains rational, irrational, rational, irrational, integers, whole numbers and natural numbers. So, among all these sets, we can say that real number is the biggest set, or real numbers is the superset. Biggest means superset. And the smallest set among this is the natural numbers, because it starts from 1, 2, 3, 4, 5, 6, etc. and so on. So, these are all well-defined collection of objects, and this is a set. Now, suppose if I ask a question. Yes. Give me the months in a year which has 30 days. Give me months in a year which has 30 days. Months in a year having 30 days or 31 days. 31 days. You can say it is January, Jan, Feb, March, April, May, June, July, August, September, October, November and December. This is a well-defined collection and it is also a set. Now, to represent a set, what is the notation that you are going to use? To represent a set, the notation we are using is double brackets. So, I said these are all sets, and the notation we are going to use is double brackets. This is a set. This is a set. And one more thing you can identify is that when you write the set, the members here in the first set 1, 2, 3, 4, 5, 6, etc. They are the members or elements of the set. Members or elements of the set. Members or elements of the set. Here the members are 0, 1, 2, 3, 4, etc. whole numbers. So, whole number is bigger than natural numbers, and the members are 0, 1, 2, 3, 4, 5, 6, etc. Now, how is member or element denoted by? The member is denoted by 2 is an element, 3 is an element, 3 is an element. minus 2 is not an element. Minus 2 is not an element. So these are the notations for members and not members. Another thing is, what you have identified is each set is unique. Unique. Like each one of you is unique. How do you identify? How do I identify each one of you? By calling out your names. Yes. In the same way, since each set is unique, each set is given a name. And the names are denoted by capital letters of the English alphabets. Here the notation is N, W, Z, Q, R. Here I can give the name as A is equal to. A is equal to. Next one, I can give an example as an even prime number. An even prime number B is equal to set 2. Even prime number is equal to set 2. So we can say that N is a set of natural numbers, W is a set of whole numbers, Z is a set of integers. Suppose if it is given as Z plus, that means you take only the positive integers. If it is Z minus, you take only the negative integers. Q, positive rational numbers and negative rational numbers. Capital R means rational numbers, irrational numbers, integers, whole numbers, natural numbers, and so on. Now, here you can say that 2 is a member of N. 3 is a member of W. Minus 2 is not an element of N. Minus 2 is not an element of N. Member and not a member of. Now, I hope you understood what is a set. What is a set? A set is a well-defined collection of objects. Well-defined. Each set is unique. So sets are given their names and they are denoted by capital letters of the English alphabets. Capital letters of the English alphabets. And after the elements, the members belonging to the set. Member and not a member. After each member, you put a comma. 1 comma, 2 comma, 3 comma, 4 comma, 5 comma, etc. Now, in some sets, when you consider these sets, you can see that the first set of natural numbers. Can you count how many numbers are there or how many members are there? Is there an n for the set of natural numbers? No, there is no n for a natural number, set of natural numbers. Likewise, whole numbers, does it have an end? In this case, no. But what about the set A? Does it have an end to the members? Yes. How many members are there? 1, 2, 3, 4, 5, 6, 7 members. And what about the set B? It has only one member. So, in sets, there can be members in which it is you can count or you cannot count. You cannot count means they are called as infinite sets. You cannot count, not countable. Not countable. Infinite sets. Whereas when you consider the set A, there are 7 members, or you can say n of A is equal to 7. There is an end for the number of elements in the set. That set is called as a finite set. It is called as a finite set. So, we have come to the next point, finite set and infinite set. Finite set and infinite set. Infinite set means the number goes on without end. Finite set means there is an end. Now, when you come to the last example, B is equal to set 2. What happened? There is only one element in that set. If there is one element in that set, it is called as a singleton set. It is called as a singleton set. Singleton set. Now a question arises. Yes, that's a good question. Sometimes here we have considered sets with elements, or one element, 7 elements, elements which cannot be counted, all those cases. Sometimes there can be a set with no elements. Now suppose when you consider a boys' school, only boys are studying in grade 11 and 12. I ask, what is the set of girls in the school? What will be your answer? C. In a boys' school, I am asking you set of girls. You will say C, there is no girls. That means there is no member in that set. All of you will give you the same answer, no member in that set. That set is called as a null set. Null set or void set or empty set. And it is denoted by the Greek notation phi. P-H-I. Phi. Null set. So null set means there are no members. There can be set with no member called null set, empty set, void set. There can be a set with one member, singleton set. There can be a set with many members which can be counted. It is a finite set. And there can be a set with the members which cannot be counted. It is called as an infinite set. Now, I hope the first part is clear to you. Yes or no? Is the first part clear to you? Yes. Okay. Now, when you come to the next thing, so let us recollect what we have discussed here. What all things we have discussed here. We have discussed what is a set. Set of natural numbers, set of whole numbers, set of integers, set of rational numbers, set of irrational numbers, and that is all included in the set of real numbers. Then you have discussed about elements of the set, not an element of the set, not an element of the set. Sets are given by names, capital letters, then finite set, infinite set, singleton set, empty set. Now, usually when you write a set A, I am asking you set of vowels. What are the set of vowels? A, E, I, O, U. So, the elements will be denoted by small letters. A, E, I, O, U, A, E, I, O, U. The elements will be denoted by small letters separated by commas, whereas the names of the set will be denoted by capital letters. So, set of A, E, I, O, U. Suppose B, set of alphabets in the letter, in the word school. So, I'll write B is equal to set S, C, H, O, L. So, you are telling one more O is missing, yes. But when you write the set, repetition is not allowed. You write it only once. Even if it is repeated 3 times, 4 times, 5 times, etc. You write it only once when you write a set. So, SCHOL. Only 2 O's are there, but you will write it only once. So, number of elements in B. Number of elements in B is equal to 5. Number of elements in B is equal to 5. Repetition is not allowed. Now, when you write the set can be written in 2 forms. Sets in 2 forms. 2 forms. One is called as a roster form. Roster form or tabular form. Second one is called as the set builder form. Set builder form. This is very important. Sets in 2 forms. You may be asked to write the set in the roster form or tabular form. Another way is write the set in the set builder form. In the roster form, what you would do is you pick out the members and specify it one after the other, specifying them elements. For example, set A, set of vowels. I write it as specifying A, E, I, O, U. I am picking out all the elements one by one and I am writing. But this is roster form. Roster form. I can write the same set in a set builder form. A is equal to set of all x such that this bar is read as such that x belongs to set of x belongs to vowels. X is an element of vowels in English alphabet. X belongs to the set of vowels in English alphabet. So you can see that here I have not written the elements, but a general form is given to you. General form is given to you. From the general form, you will say, okay, I can write what are the members of A, E, I, O, U. Suppose you are given A, E, I, O, U, you can say in the set builder form, set of all x such that this line is such that x is a vowel in the, x is an element of the vowel in English alphabet. So there are 2 forms, that is a set builder form and the roster form. Now once again we'll revise. Set, natural number, whole number, Z, rational number, Z integers, rational number, real number, element, not an element. Sets are given names and they are represented by capital letters of the English alphabet. Sets can be finite, there is an end. Infinite, there is no end, you cannot count. Singleton set, a set with a single element. Empty set, a set having no element. And when you write a set, the elements, suppose if it is the English alphabets, you have to write in small letters. The elements are written in small letters, whereas the names are written in capital letters. And after each element, you put a comma. Single brackets are used. Double brackets are used. Set B, set of alphabets in the word school. Sometimes the elements may be repeated. But even if the elements are repeated, the set while writing a set, you write it only once. Sets can be in 2 forms. One is a roster form or the tabular form, where you write all the elements. You pick out all the elements and you express it. Another one is a set builder form. Set builder form, you give the general formula of the set. For example, the same thing I have written as set of all x such that x is the So, X is an element or X is a member of the vowels in English alphabets. So that means it comes as A, E, I, O, U. Now, I hope this is clear to you. Yes or no? Yes. Okay. Now, suppose the question is, write the solution. Write the solution of x squared plus x minus 2 is equal to 0 in roster form. Roster form. So what is roster form? Roster form is specifying the elements. But here write the solution of x squared plus x minus 2 is equal to 0 in roster form. So first of all, you have to get the solution of this equation. All of you know that it is a quadratic equation. You can get the solution by using the formula. What is the formula? X is equal to, yes, what is the formula? X is equal to minus b plus or minus root of b squared minus 4ac whole divided by 2a. Or you can factorize it. Another method is just factorize it and get the solution. Now, when you are using the formula for the quadratic equation, make sure that x squared term, x term, constant term should be on the left hand side, and on the right hand side it should be 0. And most preferably the coefficient of the constant coefficient of x squared should be made positive, or you may make mistake. So here what is A? A is equal to 1, coefficient of x squared. B is equal to 1, coefficient of x. C, coefficient of the constant term, it is equal to minus 2. Minus 2. So x is equal to minus b plus or minus root of b squared minus 4 into a into c divided by 2 into a, which is minus 1 plus or minus root of 1 minus of minus plus 4 into 2 8 divided by 2, which is minus 1 plus or minus root of 9 divided by 2, that is equal to minus 1 plus or minus 3 by 2. Minus 1 plus 3 by 2 or minus 1 minus 3 by 2. 2 by 2 or minus 4 by 2, that is equal to 1 comma minus 2. So what is the solution? Solution is set 1 comma minus 2. 1 comma minus 2. This is how you do using the quadratic formula. Make sure that you have coefficient of x squared term, x term, constant term on the left hand side, 0 on the right hand side. Coefficient of x squared, most preferably make it as positive. If it is negative, make it as positive by multiplying throughout by a negative sign. Or you can factorize it, that is factorization. How do you factorize it? Find two numbers whose product is minus 2 and x minus 2 into x plus 2 into x minus 1 is equal to 0, because x into x, x squared minus x plus 2x minus 2 is equal to 0. X squared plus x minus 2 is equal to 0. Find two numbers. When you multiply, you should get minus 2. When you add, you should get plus 1x. So those who are familiar or those who are good in factorization, you can factorize it and do, or if you are confused, use the quadratic formula and complete the problem. This is how you do the question. Clear? Yes. Now, let us consider set A. The members are 1, 2, 3. Let us consider a set B. Set 1, 2. What does it mean? What do you... Yes, they are, of course, A and B are finite sets. They are finite sets. Very good. Number of elements in A is equal to 3. Number of elements in B is equal to 2. They are finite sets. And another thing what you have observed is all elements of B are in A. Elements of B are in A. Then we can say that B is a subset of A. B is a subset of A. And it is denoted by B subset A. B is a subset of A. And A is bigger set. So we can say that A is a superset of B. A is a superset of B. And the notation will be A superset of B. A is a A is a superset of B, subset and superset of B. Next one is consider the set A. Set 1, 2, 3. Now, we are going to find out n of A is equal to 3. We are going to find out what are the subsets of A. Subsets of A. What are the subsets of A? Every set is a subset of itself. That is, whatever set you take, that set itself is a subset of itself. So, the subset 1, 2, 3. That is 3 elements. Then with 2 elements, 1, 2, 1, 3, 1, 2, 1, 3, 2, 3. So with 2 elements, it's over. Then set 1, set 2, set 3, and another property is null set is a subset of every set. Null set is a subset of every set. So how many elements are there in a subset? 1, 2, 3, 4, 5, 6, 7, 8. Number of subsets is equal to number of subsets is equal to 8. And if an element A has 3 elements, number of subsets is equal to A. There is a relationship between these two. It is equal to 2 raised to 3. 2 raised to 3. If B is equal to x comma, set of x comma y, n of B is equal to 2. What are the subsets? Subsets is set of xy, set of x, set of y, and null set. So, how many are there? It is equal to 4. is equal to 2 raised to 2. So we can say that if a set has n elements, if a set has n elements, number of subsets is equal to 2 raised to n. Here 3 elements, number of subsets is equal to 8, it is 2 raised to 3. B has 2 elements, number of subsets is equal to 4, is equal to 2 raised to 2. Now, one more thing, power set. It is coming from subset. The collection of subsets is called as a power set. The collection of subsets. So what is power set? Collection of subsets is a power set. And the elements will be power set. The elements will be set 1, 2, 3, set 1, 2, set 1, 3, set 2, 3. Here the elements are 1, 2, 3. But in power set, it will be set 1, 2, 3, set 1, 2, set 1, 3, set 2, 3, set 1, set 2, set 3 and null set. So, if a set has n elements, number of subsets is equal to 2 raised to n. I think we have completed. 1 minute. Let me check. Not power set. 1 minute. I made a mistake. It's got a power set. Now, exercise. You can refer your textbook. Exercise 1.1 and 1.2. Homework. SCRT or NCRT text. Exercise 1.1, 1.2. I hope for today it is enough for you. Now, next class when you come, work out all the exercises, and there will be test paper by the end of the week. And I'll be giving you the email idea to which you have to post your answers. Okay, thank you.